Today, let's take a closer look at how the mole and some stoichiometry calculations can get us to find out what we're looking for once we've been given some information to work with. I'm on page 13 in your notes. Take a look at page 13. If you haven't got them out, you want to do so, grab them, pause the recording, and I'll wait for you right here. So in the middle of page 13, there's some reminders here. We know that 1 mole is 6.02 times 10 to the 23rd particles of something, whether those particles are atoms or ions or molecules or whatever. We know that 1 mole is going to be a GFM, a molar mass. It could be a gram atomic mass, it could be a gram molecular mass, but it's the mass of 1 mole of a substance that we're working with. We also know that 1 mole is 22.4 liters of a gas, any gas really, 22.4 liters. So those pieces of information, those constants, are going to help us make conversions between things we know and things we don't know. And so earlier in the packet I showed you a triangle, a mole triangle, where mole was in the middle of that figure, and now I'm showing you an expanded diagram. On the bottom of page 13 you see a square, this time rectangle really, and at the middle of it is the mole. But now there's 2 moles. There's moles of given information and moles of unknown. What are you looking for is on the right side of this diagram. If I draw a line all the way down through the middle here, everything on the right side of this diagram is the unknown. Everything on the left side is the known, or what's given. So this is a transitional kind of diagram. If we start with quantities of mass, then using the molar mass, the GFM right here, then I can convert it to moles of what I know, given, and then convert that from moles of given to moles of unknown. Now the way I'm going to do that is by using a mole ratio. That's what we did previously in class. The mole ratio is going to come from the balanced equation. There's one part to this diagram that's not listed that I would encourage you to add, and that has to do with particles. So really we should also add particles over here on the left. This would be particles of known, and that can be converted into known or given moles by using 1 mole over Avogadro's number. And then once you know the number of moles that you're given, you can convert that to moles that you don't know, and again using Avogadro's number, go back from the unknown moles to unknown particles. So this would return you to particles if we do this. Particles. And we would be using Avogadro's number, but this time Avogadro's number would be on the top of a conversion factor given 1 mole of something. Any substance is 1 mole of Avogadro's particles. Last thing to note is that just because you start with grams of something doesn't mean you have to end with grams of something. You could end with volume, or you could start with liters and you could end up with particles. So you don't have to begin and end with the same type of quantity. You don't have to start with grams and end with grams. And this overall diagram can give you a sense of what kind of roadmap to follow. In the beginning, you might find it quite helpful. As you progress and you practice more problems, you will find you will need it less and less, and that's what we're going for. So let me do a couple problems with you, take you through examples, and then when you come to class tomorrow, we'll just give you time to work on the problems. You can work on your own or in small groups, and I can walk around and help as needed. And if you're flying through it, that's great. We can move on to the next thing. So, for example, here is a mass problem. We call them mass because I know you're going to find this hard to believe, but they start with grams and end with grams. So these type of problems, they say exactly what they are. So first you want to make sure that your equation is balanced. And in this case, I see that I have 2 sodium over here on the right, so I'm going to need a 2 in front of my sodium hydroxide. That's going to cause me to need a 2 over here, and then I believe I'm going to need a 2 here, and that should do it. So I now have 4 hydrogen on each side. Nope, that's not it. So OH 2, I did not need that. I did not need this 2. See, sometimes you have to look at what you've been given and try again. That looks better. 2 sodium on each side, 2 hydroxide. I'm thinking of this as HOH. That's why I've got 2 hydroxide. And then I have 2 hydrogen. No, I have 2 hydrogen here, 2 hydrogen here. Now we're good to go. So don't forget, too, that these are understood to be 1s. You do not have to put them in there, but you can. All right, so the problem we're being asked to consider is this. If I have 60 grams of sodium hydroxide, how many grams of sulfuric acid? This is what I don't know. I want to know how many grams, that's my unknown, will react with what I do know, which is the 60 grams of the sodium hydroxide. So I'm going to start with a known mass, 60 grams of sodium hydroxide, NaOH. Notice I'm writing not only the units, but I'm writing what it is. So in this case, sodium hydroxide, because we're going to go from what we know to what we don't know. I want to get rid of grams of sodium hydroxide. So I'm going to put that on the bottom of my conversion factor, NaOH, and 1 mole. I'm converting to moles straight off, 1 mole of NaOH. The molar mass of sodium hydroxide, if you want to take a minute and add it up, you can, or I'll do some quick math here. This is going to be 23 plus 16, that's 39, plus 1 is 40. 40 grams per mole for sodium hydroxide. That's going to allow grams of sodium hydroxide to cancel out. Now I have moles of sodium hydroxide, known moles. I want to get rid of my moles of sodium hydroxide in favor of my moles of my unknown. The unknown is sulfuric acid, so I'll put moles of H2SO4 on the top. That's what I'm looking for, SO4. So those moles of H2SO4 and that relationship that it has with sodium hydroxide come from the numbers that are the coefficients in the equation. So H2SO4 has a 1 in front of it, right here. So that's what I use. Sodium hydroxide has a 2 in front of it. That's what I use here. Even trying to color code this for you as we walk through it. At this point, moles of sodium hydroxide cancel out, but that leaves me with moles of sulfuric acid, which is not what I'm looking for. I'm looking for sulfuric acid, but I'm looking for grams, not moles. So we got to get rid of moles of H2SO4. That'll go in the denominator in favor of grams of sulfuric acid. Grams H2SO4. And again, do some quick math. You can add these up yourself if you would like. I will tell you that it's 98.1 grams. That is the molar mass of sulfuric acid. And at this point, moles of sulfuric acid cancel out in favor of grams of sulfuric acid, and that is what I was looking for, H2SO4. So now I would do some math and crunch some numbers. And when you do that, multiply 60 times 98.1. I'm going to do this. You're going to hear me clicking my calculator buttons. 98.1, and then divide that by 40 times 2, which is 80. I get 73.575. 73.575. If I'm figuring out sig figs, I see 2 given in my problem. And so if I round this to 2 sig figs, that would leave me with an answer of 74 grams of sulfuric acid. That is my answer. So there you go. There's a mass problem. You notice that I started with grams and I ended with grams here, right here. So that's, for example, one of those. Let's do a different kind. We'll slide down to page 15 where we will find volume problems. We are going to be starting with a volume and ending with a volume. But first, you have to balance the equation. So if you want to take a moment and do that while I clear out the screen here, we got some stray marks to take care of. We can go ahead and do that. Okay, balanced equation means that there's a 2 right here in front of the HCl. Very simple equation. We'll keep this one simple. So what are we looking for? That's right. I hope you were thinking liters of HCl. How many liters of HCl will be produced by the reaction of 10 liters, that's our known, hydrogen. 10 liters of hydrogen. So be careful. Make sure that you know what the substance is that's being measured. Sometimes it's even helpful to write in 10 liters of hydrogen. I'm going to write it right above where the hydrogen is and know that I'm looking for HCl. This is in liters too. So sometimes that draws my attention to the coefficients that are going to be important in my calculation. Okay, so 10 liters of hydrogen is what I start with. I want to convert that to moles of hydrogen. So 1 mole of hydrogen in liters would be 22.4. Any guess? 22.4 liters of hydrogen. And that would cause moles. Wrong. Undo. See, sometimes I get carried away and start doing this without thinking. Let's try that again. So what we're going to do is put liters on the bottom. Were you thinking I was upside down? I was. You got me. 22.4 liters per mole. That's what we want to get rid of. In this case, it's hydrogen. So I'll write the hydrogen in there. Okay, liters of hydrogen cancels out. Now, moles of hydrogen is what I want to get rid of because I'm looking for moles of HCl. And the coefficients that go with these two quantities, HCl has a 2 in front of it from the equation. The hydrogen is 1. It's a 2-to-1 ratio. That allows me to cancel out moles of hydrogen in favor of moles of HCl, and I have one last step. Here's where moles goes on the bottom, moles of HCl, and it is a gas, so it is 22.4 liters of any gas goes on the top. And moles of HCl will cancel out. Hey, wait a minute. What else cancels out? 22.4 liters on the top, 22.4 liters on the bottom. You don't even have to grab your calculator because the calculation is simply 10 times 2, which is 20 liters of HCl. That is your answer. So the fantastic part about a volume calculation is that whatever you have, as long as it starts in liters and whatever you end up with is also in liters, this quantity here, this relationship will always be the inverse of the other. In fact, when we interpreted equations using the coefficients, these coefficients, I'll even write in the 1 here, not only do they stand for moles, 1 mole of hydrogen and 1 mole of chlorine make 2 moles of hydrogen chloride, they also stand for molar volumes. 22.4 liters here, 22.4 liters here would give you 44.8 liters here. And that's why this works. So if it's a volume problem, you can kind of ignore these two steps and really just use the mole ratio right here in the middle. That's all you need. One last example I'll do with you. Mass volume. So this is a mixed problem. So if we were to balance this equation, for starters, I'm going to need a 2 here. And that makes sure that I have 2 hydrogen and 2 chlorine on each side. In this problem, I'm looking for the mass of magnesium. So how many grams of magnesium? And I'm given half a liter of hydrogen. 0.5 liters of hydrogen is what will be produced, but I want to know how much magnesium to start with. So even though ultimately that's going to tell me a reactant, I want to start with this number, this 0.5 liters, because calculation-wise, that's what I know. So 0.5 liters of hydrogen. First thing to do is to convert it to moles. So 22.4 liters of hydrogen per mole. 1 mole on the top, because that's what that will leave me with. And of course, liters and liters will cancel out. Now I need a mole ratio. I want to get rid of moles of hydrogen because I want to know about moles of magnesium. Moles of magnesium goes on the top. And the ratio here is 1 to 1. 1 to 1. That's nice. That's going to make my calculation a lot easier. And then my last step, 1 mole of magnesium. This time I'm looking for mass. So the grams of magnesium, I'll have to consult my periodic table, and I will find that it's 24.3 grams of magnesium. Moles of magnesium cancel out and leave me with 24.3 grams times 0.5 divided by 22.4. 0.5. 0.5424. But my problem only gave me 1 sig fig, so I'm going to stay with 1 sig fig. And my answer, ironically, coincidentally, is the same number as what I started with. Different unit, different substance. Sometimes that will happen. It's pure coincidence on this one. Okay, that's about it. I hope you have followed along, filled in some notes. Come to class tomorrow and we'll work through some of these together.